Good afternoon, everyone. My name is Faris Ibrahim, and for this demo, I'm going to be presenting the appraisals prediction model for this week's HeadStarter project. So, as we can see, this is my Colab notebook, and I'm going to address deploying this model at the end of this video. As we can see, we have the JSON dataset that was from the repo provided by Hamza, and this is the Colab notebook that has the model. So since this is basic machine learning, we're just importing every single machine learning package we need. So pandas, numpy, matplotlib, and seaborn. And and for this cell, since this is a JSON dataset, I'm importing that using the JSON package from Colab, and then I am using that. I'm parsing that into a data frame. Now this is since the repo itself addressed that this dataset would need appropriate cleaning, so we know that we cannot use this dataset as it was imported because the data itself does not really make enough sense. We only have one column, which is appraisals, which is not actually true. This has to be, in a sense, pre-processed. So as we can see, this is the pre-process function. So again, I'm importing the dataset file, and then I'm getting the column, and I am forming dictionaries from every single entry in that column. So as you can see, we had order ID, subject ID, address, and then I'm parsing that. I'm parsing these different entries into different dictionaries, and the key is the column name itself. So as you can see, appraisals is the appraisals column. The records is the subject records that I'm getting, and now for the data cleaning, I only had one missing numbats entry, so I just decided to fill that with a random value, which is 2 to 0. And just checking again if we have any other null values, numbats. This should be 0, like the NA value should be 0 here. And yeah, for other columns like the numbeds, which is an integer column, I'm filling it in using the median value. So again, this should render out a 0 missing value. And then this is just exploring the data, the different entries, and then checking which columns are of type object and which columns are of type numeric, whether it's int or float. And then since the columns in this data set, like the type, the subject, not the address, the municipality, the conditions, the basically these columns, since these are technically categories, then I'm converting them into categories, and I'm encoding them using their own category codes. So, and then for these categorical columns, if some of the entries are missing, I'm encoding them with the codes. If they're not missing, so in the case of the first few columns, like the type, the order ID, the address, the city, province, these did not have any missing values. So in that case, I did not encode them with any codes. Moving on to the encoded dataset now. Again, this time I'm looking for any numeric columns, and I'm filling them with their median values. And then after filling in all the missing numerical columns with their median values, I'm loading that. The encoded data now is loaded back to a CSV folder. And coming to the model itself, so since this is a recommendation system that is going to look for the top 3 similar appraisals for a subject appraisal, I'm using a k-neighbors classifier that's going to use a couple features from not every feature from the dataset, but most notable features from the dataset, the ones that Hamza explained. So the similar type, whether it's a condo, bedroom, detached, the sale price, the GLA, the year that this property was built in, and this is the X scale column because I'm normalizing the feature values. And now this is the X clean column, and these are the features, the most important features, I would say, depending on what was given in the HeadStarter the presentation given by Hamza. These are the model features, and then since obviously one thing I found that I needed to parse was the numBaths, since that was a string. I wasn't able to use that to train my model. I had to convert it into an integer, so this is just a helper function for that. And now coming into the actual data splits, where the subjects are the entries that have the subject type from the type column, and the potential comparison properties are anything else except that subject. So the model is supposed to return the top 3 similar properties. These are the feature weights. Like I said, this was based on the features given in the presentation slides by Hamza. And now coming to the model itself, after splitting our data and fitting our model, coming into the actual recommendation function where we get the top 3 similar properties. So we do that based on the structure type, whether it's a condo or a detached or a 2-bedroom, the most important feature out of them, and that's obviously shown by the huge weight, the highest weight out of them all, which is 3. And then if that's not the case, then we use all the potential matches. So with respect, obviously, to the sale date. So moving on, and now testing this model on a test subject, a random test subject from the dataset itself. And so yeah, as we can see, so a sample example was 142,950 Oakview, Kingston, in Ontario, and the top 3 properties recommended for similarity are these 3. And as we can see, the feature importance graph shows that the effective date, or essentially the effective date, is derived from the sort of hinted at from the year built. And then we have other features like type, address, order ID, and city, province. And these are the metrics of the model. So this is the R-square score for the training set and for the test set. As you can see, it's fairly better than random, I would say. And then for explainability, I'm using Lime and Shap, but I think for this notebook I'm using Shap mainly. Now, since I'm using Shap, I have to explain the features, like the output of the model predicted based on what features were more important. And I think Shap is, I think it's derived from game theory that also works that way, basically seeing which players contribute most to the outcome of a game. So in this case, using Shap to see which features contribute most to the output of a model. And yeah, as we can see, according to Shap, the structure type, whether it's a subject or anything else, is the most important. The years built is also important. The GLA is also important. And this is me saving the model. And yeah, that's my demo.